All right, let's get started, guys. Let's get started. Hey, guys. All right, calculate the force needed to bring a 950 kg car to rest from a speed of 90 kilometers per hour in a distance of 120 meters, a fairly typical distance for a non-panic stop. That's an awfully long distance. 120 meters is one and a half football field length. That's, yeah. Bad brakes. Anyway, suppose instead the car hits a concrete abutment at full speed and is brought to a stop in 2 meters. Calculate the force exerted on the car and compare it with the force found in part A. Okay. So, um, well, let's convert the speed into meters per second first. This is 90. When you're converting kilometers to meters per second, you're essentially dividing by 3.6. Okay. So you are trying to bring this car to a stop from 25 meters per second. Okay. What is it that you're calculating? Calculate the force. Okay, so here's the car. The force needs to be in that direction while the car is moving. We'll call this the displacement. And again, the angle is 180 degrees. Brakes are friction forces. So anyway, the work done by the force is Fs cosine 180. And okay, so there's the weight of the car that's being balanced by the normal force. Okay, so the net work done, this is minus Fs. The net work done is the work done by the braking force. And that's the only force that does work, and that's equal to minus Fs, and that's equal to final kinetic energy minus initial kinetic energy. That's the only force that's doing work. And final kinetic energy is 0. So Fs is equal to initial kinetic energy. So the braking force did that much work. Okay, so that was the magnitude of the force, and now we can put in the numbers. 950 kgs. Okay, and that'll work out in newtons. So the braking force is 2500 newtons. Okay. All right. In part B, suppose instead the car hit a concrete abutment at full speed and is brought to stop in 2 meters. So now, what you're doing is, instead of this being S being 120 meters, it's 2 meters. And when this is small, the force is much larger. Okay, so let's calculate that force now. So the force was mv squared by 2s, and smaller the force, greater the, smaller the stopping distance, greater the force. Yeah. And so this is 950 kgs. Well, so this is 2 meters instead of 120 meters, so the force is 60 times greater than the old force. You guys understand? I don't have to do all of that, so this is 60 times the old force. Did you guys understand that? Not a bit. The old force had 120 on it. What you want is, if you, okay, the old force is some constant times 120. The new force is the same thing except that 20 with 2 meters underneath. So if you take 60 times the old force, 60, gives you the 2. Okay, so it's 60 times the old force. But don't worry about that. Let me calculate it. So I'll calculate it. 25 meters per second, 2 times 2 meters. Okay, so now the force stopping the car is that. Okay, and just to show you, we'll call this F2 and this F1. Let's calculate F2 by F1. 148.438 Newton divided by 2,474 newtons. And that's 60 as promised. But here's what we'll do. We'll calculate the acceleration each time. Okay, so the stopping force when you're applying the brakes over normal distance is force divided by the mass. Okay, and 2.6 meters per second squared. So the deceleration is 2.6 divided by 9.8. Again, 0.27 G. Okay, so the braking force is 0.27 G. All right, so the braking force is 1/4 of the weight of the car. Okay. In the second case, it's 60 times that. But and I'll let you guys calculate that. Into 60 is 1560. Okay.
16 G is referring to the force of gravity.
I'm sorry?
Is the G in each of these numbers
Is the acceleration due to gravity. So if you were driving that car and your car happens to hit the wall, if you stopped over a distance of 2 meters, okay, so if you were driving the car and your airbag didn't deploy, you'd get stopped by the steering wheel, and that's a hard stop. That's harder than this. That can be fatal. With an airbag, you're trying to, even if the airbag won't stop you over a distance of 2 meters, but the airbag along with the car crumbling, there you're stopping over a greater distance than 2 meters, and that's how you get saved. Then your deceleration is less than 16 G.
Oh, okay.
Okay. So that's the safety measure. Okay, so you want the crumple zone and an airbag so that the person driving the car experiences an acceleration less than 16 G.